This is John Ahrens. What you're looking at is the light bulb being lit, and this is a milliamp meter that is between the light bulb and a battery. It's running on a frequency, and as you can see, there's 0 milliamps going through this. Actually, it's 0. This meter here is across the battery. This meter here is an analog meter across the battery. Now you're probably asking, so what? Well, that's a good question. So in effect, what we're showing is there's no battery loss, and yet this is an amp meter in series with the battery. So theoretically, what we've got is a light and a circuit that's drawing 0.20 milliamps. But for some reason, we're not showing any loss on the battery. Now what happens here is this gets out of sync again. You can see the meter moving a slight bit, and I've got to keep it in tune back to 0 again. And by doing that, the volts across the meter, the voltage on the battery stays the same. And we're using we're definitely using energy here, 0.20, but not according to our two other meters. So where is the voltage going? Where's the amps going? I don't know. The only logical conclusion is it's charging the battery back up again. This is the digital meter that's across the battery. Of course, it's moving because it's digital, but this is not digital, and it's staying pretty steady. So we're showing a draw of 0.20 in the circuit, and yet somehow or other the battery is being charged back up because we're showing no loss. And at the same time we're running this light. But according to our meters, there's no energy going through the light. There's no current. This is John Ahrens with Hydrogen Tap. Interesting, right? So this meter here is across the battery. That meter is in series with the light. Those numbers you see there, that 2 is actually 0.2 of a milliamp. And as you can see, the deflection is to 0. This is in series with the battery, which is showing that there's 0.20 milliamps being used up in the circuit. And yet, and to get more accurate over here, there's actually some time that's showing an actual charge higher than. So there we are. This is John Ahrens, and welcome to my life.